Next one has the prove the following. Prove that the signals. First one, e power minus at u of t and minus e power minus t will have same Laplace transform, but differ in its ROC. Let it will be given as, that is, it is having the same x of s but differ in its ROC. That we need to prove it. For that, consider the first signal as, or x of t is here as e power minus at u of t. Therefore, its Laplace transform as x of s is equal to, generally we will take the bilateral Laplace transform from here cases, that's from minus infinity to infinity, x of t e power minus st dt. Put in the bilateral Laplace transform, x of t is equal to e power minus at u of t, e power minus st dt. Because of the u of t, the limits will be from 0 to infinity, and combine the two exponentials, s plus a of t dt. Okay, when we perform the integration, s plus a of t by minus of s plus a with the limits from the 0 to infinity. When we substitute infinity at here, e power minus infinity minus e power 0 by minus of s plus a. Provided this will be happen whenever the s plus a is greater than 0 only. That's why the region of convergence here will become s plus a will be greater than, that's RE of s plus a should be greater than 0. Therefore, RE of s will be greater than minus a. That's why when we plot this particular one, that's region of convergence, take the minus a. Beyond this particular minus a, it will be our region of convergence, which covers some part of the negative and full positive cycles. That is our region of convergence. And when we simplify this one, minus minus gets cancelled, which is equal to 1 by s plus a. This is our Laplace transform x of s. Okay, in the first case we have got it as 1 by s plus a, and the region of convergence is RE of s will be greater than minus a. For the second signal, let that x of t is equal to minus e power minus at u of minus t, which is being given as, let in this particular case, that's e power minus at u of minus t. Therefore, our x of s is, again take the bilateral from minus infinity to infinity, x of t e power minus st dt. Substitute what is x of t, that's minus e power minus at u of minus t e power minus st dt. Because of the u of minus t, the limits will be from minus infinity to 0, minus e power minus at e power minus st dt. As this particular minus will be changed, therefore the limit will be from 0 to infinity. And take this particular as e power minus of s plus a of t dt. Okay, that's the change. This minus is as it is. To change this particular limits from minus infinity to 0, from 0 to infinity. Therefore, we need to keep a minus sign at here. That's it will be of the plus sign. That is e power s plus a of t dt. To change the limits from, initial limits is from minus infinity to 0. Now we are changing it to 0 to infinity. Therefore, here minuses will be gone. We need to keep the plus, e power s plus a of t dt. Then minus into this particular integration e power s plus a of t by s plus a with the limits from 0 to infinity. When we substitute infinity at here, whenever this one is positive, we'll directly get e power infinity. That's why this entire thing should be said to be negative now. That's why Re of s plus a should be less than 0. Then only we'll get this output as e power minus infinity. Otherwise it will be the plus infinity only. When it is been positive, here it is plus infinity. Whenever we'll take it as a negative, then only here minus infinity. Minus e power 0 by this one as the real minus of, that is s plus a, then minus this one as 0 minus 1 by s plus a. Therefore we'll get the same 1 by s plus a, which is nothing but our x of s, but the region of convergence is Re of s plus a will be less than 0. Therefore when we plot that particular graph, this as minus a, draw one particular line, this is j omega axis, this is sigma axis, then minus a, below this minus a will have the region of convergence. Below the region of this below the minus a will have the region of convergence. Here above the minus a will have the region of convergence with the Laplace transform as same one, that's 1 by s plus a. Here also it will be the 1 by s plus a only, but the region of convergence will be different. That means this was been called as an positive sided or right sided signal. This was called as a left sided signal. As u of t, it is a right sided signal, and u of minus t will be a left sided signal. On conclusions, it says that for a right sided signal e power minus a t u of t, the region of convergence will be greater than minus a, that's Re of s will be greater than minus a. It is right of the rightmost pole of this was being called as a pole, right of the rightmost pole, and for the left sided signal, the region of convergence will be left of the leftmost pole, where the pole is at minus a. In both the cases, the pole is at minus a. For a right sided signal, the ROC is right of the rightmost pole, and for the left sided signal, the ROC is left of the leftmost pole. Right? That is the question where the Laplace transforms will be same, but it is differ in its ROC, region of convergence.